Alright guys, in today's class we are going to concentrate on mole calculation and all the rest. So I want you guys to pay attention because I'm giving you a background of what the mole concept is all about, and this mole concept will lead us into stoichiometry. Okay, so let's go. In more concepts, what we are looking at are number of moles is mass over molar mass. Number of moles is mass over molar mass. So the mass of a substance is measured in gram, while the molar mass of a compound is measured in gram per mole. That is the first thing you will need to know. Mass over molar mass. So we call that one equation 1. We also have number of moles is concentration. Number of moles is concentration. This concentration must be measured in mole per dm cube. This concentration must be measured in mole per dm cube. Multiply by volume. This volume is in dm cube. Then you don't need to divide it by 1000. So this one, we call this one equation 2. So it means number of moles is concentration that is measured in mole per dm cube times volume. The volume is measured in dm cube. You don't need to divide by 1000. Whereas if you are given a volume and the volume is measured in cm cube, then you need to apply the second formula. That will be concentration times volume. If your volume is given in cm cube, then you need to divide it by 1000. The question is why? Why do you have to divide it by 1000? Because volume can be measured. Volume can be measured either in cm cube or can be measured in dm cube. And what is the relationship between cm cube and dm cube? 1000 cm cube is equal to 1 dm cube. That's the reason why we had to divide by 1000. That's the reason why we had to divide by 1000. So that's number 3 equation 1, 2, 3. Then we can start equating this. Why? Because mass over molar mass is number of moles. Concentration in mole per dm cube times volume in dm cube is number of moles. All these 1, 2, 3, they are all moles. So I can equate them. Very simple. I will say equation 1, that's mass over molar mass. Mass over molar mass, that's equation 1, can give us equal to, equate it with equation 2. Concentration times volume, provided your volume is in dm cube. That will be equation 4. So for equation 4, mass over molar mass equal to concentration times volume in dm cube, that's equation 4. Okay, so what I did was I just equated equation 1 and 2. That's what I did. Okay, so let's go to equation number 5. So in equation number 5, what I'm going to do is I'm going to say mass over molar mass. MR represents molar mass equal to, then I'm equating with this one, concentration times volume If my volume is in cm cube, all I need to do is divide it by 1000. That is equation 5. So you have equation 1, we have equation 2, we have equation 3, and we have equation 5. Alright, very simple. Now 1, 2, 3, 4, 5, we are going to use it now. The very first thing is, as a chemistry student, you need to know how to write a correct chemical formula as well as a balanced chemical equation. But not to worry. Why? Because those topics will be taken separately. I just want to show you a few things. Now, what are the few things I want to show you? Now, I want everybody to pay attention. Number 1, I'll give you some questions and we can now play with it. What is that? I can say, how do we calculate? That's the first thing. Finding molecular mass. How do we get molecular mass? As simple as this thing is, I just want us to go over it. And some people say, no, I already knew this one. No problem, let's just go over it. Did I call it molar mass or call it relative molecular mass? Did I call it molar mass or call it relative molecular mass? So did I call it molar mass or relative molecular mass? Now, how do we look for it? All you need to do is to sum up all the individual atomic masses given to you in a question. So let's look at it this way. Number 1, if I say find I'm going to have MR, subscript R for molar mass. So find the molar mass of carbon dioxide. Very simple. You'll be given in the question that carbon is 12 and oxygen is 16. You'll be given in the question. So don't worry, you're given this one. Always, 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 you'll be given. So what do? Find the relative molecular mass of carbon dioxide. Simple. So so we look at this solution. We'll see solution. So what is the solution to this one? Very simple. You say MR, that's relative molecular mass of carbon dioxide, is a sum of all the relative atomic masses. So that's going to give us, what is carbon? Carbon is 12. Plus, what is oxygen? Oxygen is 16. But remember that you are given 2 of oxygen. So multiply that by 2. If you do this math, it's going to give you 44. And then put the unit, 44 gram per mole. That's how to find the molar mass. Very simple. Molar mass is found or determined by adding all the individual atomic masses in the compound. Fine. Let's go to number 2. Question number 2. Just want to do 2 more then before we move on. Question number 2. If I ask you, find the relative molecular mass of sodium trioxocarbonate 4. Find the relative atomic mass or molecular mass rather of sodium trioxocarbonate 4. Then you are going to have sodium will be given as 23. Okay. Carbon will be given as 12. No problem. Then oxygen will be given as 16. Very simple. All you need to do is to sum up all these relative atomic masses. So the relative atomic mass or masses, just sum them up. So what that's going to give us, the molar mass of sodium trioxocarbonate 4. I'm looking at solution now. The molar mass of sodium, the molar mass of sodium trioxocarbonate 4. What is it? Sodium atomicity. So what's that? I just introduced a word and I want us to look at that. What's atomicity? Is the number of atoms present in a molecule.